Good afternoon, ladies and gentlemen. Welcome on a Friday afternoon to a very special lecture. My role is simply to say welcome to the Oxford Martin School, welcome to my dear friend and admired colleague, researcher, champion of the earth, Ram. But really, the Oxford Martin School is very pleased that today with the Oxford Climate Research Network, we were able to bring to you one of the great voices of climate change research, but as you will see, far beyond that. So Philip, thank you again for making this possible, and it's a great pleasure to have you all here. Thank you.
Well, thank you, Achim, actually, for hosting us here. And also, it's a good sign that we are here as a sign of a new collaboration a bit between the Oxford networks of the environment, of which the Climate Network is one of them, and the Martin School. So I think this is a really nice start to be hosted here. So my name is Philip Stier. I'm currently the convener of the Oxford Climate Research Networks. For those of you who don't know the network, so we are networks of and for the researchers at the University of Oxford doing climate research. The network has about 200 members or so covering a vast range of different research areas. And as typical for Oxford, we managed to be scattered across 18 different departments and schools, which also explains why we need a network to actually get together and talk to each other from time to time. So for us, the annual lecture is really the flagship event of the Climate Network. It's one lecture we have a year where we get together and listen to some inspiration. And typically the pressure is on to find a really good speaker, because as you can imagine, if you have to satisfy 18 different departments and schools, there's some tensions. And so today it's our pleasure, and we're really delighted to have Professor Ramanathan here, because pretty much on his own, he spans basically the breadth of the network, as you will see in his talk, but he doesn't really neglect the depth either, so it's very exciting. So Ram studied engineering in India and holds a master's degree from the Indian Institute of Science, and then he went on to the US, where he actually worked on his PhD on radiative transfer and spectroscopy. And then he took on a number of research posts and was then also PI of the really groundbreaking NASA mission, the Earth Radiation Budget Experiment, which still influences lots of research today. He then moved on to become a professor at the University of Chicago, didn't stay there too long, and then moved on to Scripps in sunny California, where he's been since 27 years-ish or so, and holds a big group there related to clouds, aerosols, and many other topics. But more recently, so he worked a lot then on aerosols and their effects on climate and air pollution. But then more recently, he really shifted his attention to solutions, and that's quite exciting. And he started a project to reduce emissions from carbon dioxide and aerosols and other things through provision of inexpensive solar cookers in India. And he engages quite heavily now in the communication of climate to a wide range of different audiences. So Ram has received numerous awards, so this is where I probably have to cut it short. So including the Fellowship of the American Association for the Advancement of Sciences, American Meteorological Society, American Geophysical Union, National Academy of Sciences, and importantly also the Pontifical Academy of Sciences. But for the sake of time, I'll stop here, because the list would be far too long to read it out to the end, and hand over to Ram, who will speak today on climate change morphing into an existing problem. Thank you.
Thank you, Achim, and thank you, Philip. It's a great honor for me to be giving this lecture at Oxford University. I visited this place 2 times, and both times as a tourist, and so it's a privilege to be here. Let me just right off the bat address the issue of existential. And I started working in this field 47 years ago. You can now guess my age. And I have never used the word existential. And I've never thought of this in the climate change problem in that context. So it's appropriate for me to give you some background of how I got into climate change science. I was an engineer in India. I hated engineering, simply not because of the field. In India at that time, you couldn't do anything. We were importing all the stuff. There was nothing creative to do. But at the same time, I came to the US primarily to get a quick engineering degree and joined General Motors. And my dream was to own the Impala, Chevy Impala. That's the only reason I went to the US, not for higher studies. And climate change was the last thing in my mind. So I landed in the US January 1970 on a very cold day. Next day, I meet my advisor, who was a well-known person in engineering. Just sitting in front of him, thinking he's going to tell me what to do in engineering, and he told me he was very excited. So he said, you know, I've changed my field. I want us to work on the climate of Mars and Venus. Honestly, I grew up in small towns in India. There was the first time I had uttered the word Mars and Venus. I couldn't say anything to him because inside myself, I saw my Chevy Impala evaporating away. I'll tell you what happened to my Impala dream towards the end if I have time. So primarily what I did was collect data on the Earth's climate. How do we understand it? From an observation experimental viewpoint, starting from 76. So 5-6 years ago, I went back and looked at all the data I had collected. And the change I was seeing, it was so drastic. Then I started to entertain the idea, what I thought was improbable was not looking that improbable anymore. So I'd like to quickly tell you what I mean by existential threat and walk you through the science which drove me to that conclusion. And now what I'm doing to prevent that improbable from happening, okay? So I normally think people are going to forget everything I say within 10 days. I have calibrated that 10 days. So if you forget everything, this one thing I'd like you to take home. The climate change problem can reach crisis levels this century, affecting everyone. And it could happen a lot sooner than you think. So my conclusion is that it's an urgent problem and requires urgent solutions. I hope to give you scientific data to at least let you know why I came to the conclusion. After I concluded myself 5 years ago, it's going into the existential threat area. I decided I have to personalize this problem. Only then I'll think of the solutions. So my way of personalizing it is my 3 grandchildren. The little guy on the left-hand side is 5 years old. Let's see what he's going to face as he grows up. Time being, ignore that red curve. Start on the grandson's life I'm going to forecast. He's 5 years now. So by the time he turns 15 to 18, I have a 3-year uncertainty here. We're going to shoot past the 1.5 degree warming. So you can ask, what's the big deal about 1.5 degrees? To go back and look at the climate when the planet was 1.5 degrees warm, you have to go back 130,000 years ago to the Eemian period. And just last year, scientists had discovered that the sea level, just with the 1.5 degree warming, was higher by about 6 meters. And for those of my American colleagues here, I'll convert it into feet. It's about 20 feet, okay? But we don't know how long it took, decades or centuries, still uncertain. And then by the time Ian turns 35, that's 2050, we're going to shoot past the 2 degrees, okay? This was my projection. About 7-8 years ago, I derived this. I'll tell you why how I'm feeling certain about these two numbers. And then now let's go to the red curve. IPCC and many scientists, particularly some of the lead work here was done by Miles Allen and others at Oxford, that if you continue on business as usual, you're going to reach 4-degree warming. What you need to know is that we can't predict climate change. All we know is probability. So that 4-degree warming, what the correct way to interpret that, there is a 50% probability it'll exceed 4 degrees. And there is a 50% probability it could be less than 4, okay? So if you drew out the probability distribution, this particular distribution which we used with Monte Carlo simulations was really derived by a mathematician and a climate scientist at the University of Washington, Seattle, 8, 9 years ago. So that allows for a probability of 5% of 6 degrees and 1% 8 degrees. So as you know, 5% probability is 1 in 20 chance of happening. We may think it's a low probability, but if you personalize that, if there is a 1 into 20 odds of the plane I'm going to take from Heathrow, it has the odds of falling down, I'm going to beg Oxford to appoint me here, never get on a plane. Think about that. But we are willing to send our children and grandchildren on that plane. So that's what I mean by personal. We have to think about it. What would it mean to us? So I categorized it. The dangerous part is basically IPCC definition. Somewhere between 1.5 and 2 when you pass, they call it dangerous. So I had added 2 categories, 3 to 5, and I'll try to give you my justification. Catastrophic, and beyond 5, it's unknown. That's what I'm still reluctant to put the word existential in my papers. I hope that's not going to happen. So the question mark is, this is the first week I'm trying this, my findings. So if I get a pushback from some in the audience, I'm not going to repeat the words, I'll just add one more question mark. So the question mark just simply means no one can really say what is catastrophic and what is unknown. But my point today is the time has come for at least climate scientists to think about the worst possible consequences. Not only the mean, it's our duty to inform the public. We are sitting on this curve for the last 6 years. We are not ready to talk about this, okay? So first thing is, we have to know we're all in this together, rich and poor, old and young. But I'm going to show a scientific way of why that's the case. So what I'm going to show you is air pass, how fast air moves around. But I'm showing you water vapor. Water vapor is a gas, the same way all the pollutants would be distributed. No. How do we turn on? Oh, we can do it first. Yeah. First, watch China. I have documented with my unmanned aircraft. This comes from a model simulation from a climate model I helped develop about 25 years ago. Air from China goes into the US in about 5 days. My UAV has tracked it down to 4.5 days. So where the Chinese are sending their gift to the US, we Americans send our gift to you in 2.5 days. But the vast pollution from US goes over UK and Europe. And then you return the favor by sending your pollution to China in 3 to 4 days. We are never going to solve this problem by pointing fingers at each other. We're all in this together. Okay? So many politicians are arguing pointing fingers should see this. So now let's talk about CO2. I drove from a remote place from the northeast of here. Took me an hour and a half. What came out of the tailpipe, the gas, hydrocarbons, the carbon combined with oxygen from CO2, 45% of the CO2 will be here for 100 years. And 20% of the CO2 will be here for 1,000 years. Okay? So in that time, the CO2 covers the whole planet like a blanket. How heavy is that blanket? Since the time of the Industrial Revolution, we have emitted 2 trillion tons. I know there's a confusion between American billion and European billion. So the trillion is 2 followed by 12 zeros, okay? And 1,000 billion is a trillion. About 45% has stayed in the atmosphere. It's about 930 billion tons of CO2. Just imagine the sheer weight of it. It's equivalent to 450 billion cars rotating around the planet. Unfortunately, it's in the gaseous form. If it was solid, our sky would be obscured with our cars, which we toss up, okay? So why should we worry about this blanket? So let me take you to the bedroom, but please don't go to sleep on me. So on a cold winter night, you put a blanket, and it keeps you warm. The blanket doesn't give any heat, it just traps your body heat. That's exactly what CO2 does. The planet emits infrared radiation, infrared heat, which you detect from infrared cameras. Carbon dioxide is very efficient in trapping it. So the planet gets warm, okay? I need to give you one more background. So this is a schematic. Whenever I look at it, I see my American bias. I start with US. Next time I'll change it to the European. So we think of the sunlight coming in 100%. Not all of it is absorbed, but about 30% is reflected back to space. We call it the albedo. Heats the planet. The planet wants to give off this heat as radiation. And so it's all in balance, okay? And if there was no atmosphere there, the planet would have been frozen, close to about 35 to 40 degrees colder. Fortunately for us, nature gave us a beautiful greenhouse blanket, water vapor and CO2. CO2 is not only a pollutant, it's also a biogenic gas. And those gases, the greenhouse effect, the blanket effect of water vapor and CO2 is what makes this planet habitable. What we have done is added to the thickness of the blanket, okay? Until 75, the community thought primary greenhouse we have to worry about is carbon dioxide. In fact, the famous Swedish Academy of Science published a report. But remember, I was then an engineering student. The last thing in my mind was climate change. So I've never read any of the climate change literature. But I'd done some quantum mechanics in my graduate school. So what I found is chlorofluorocarbons, which was used as refrigerants and propellants. We know, once you learn quantum mechanics, you know immediately any polyatomic molecule is an enormously powerful, by and large, greenhouse effect. So I found the CF3 as Freon 11 and 12, now we call it. Each ton of it had the same greenhouse effect as more than 10,000 tons of CO2, super pollutants. Fortunately for the planet, CFCs were banned by the Montreal Protocol. But the Montreal Protocol did not recognize my work on the climate change. So they replaced CFCs with HFCs, which is also a super potent greenhouse gas, 1,000 to 4,000 times. And under Achim Steiner's UNEP leadership, they used the Montreal Protocol, recognized the greenhouse effect, recognized the climate change, and banned HFCs, phase out HFCs. It's called the Kigali Amendment, which happened. So I had to wait 41 years to see my work do some good, okay? The next thing, this was the paper which killed my Impala dream. By the time, after 1975, within 3-4 years, there was a mad rush to see there must be other greenhouse gases. Numerous others were discovered, methane, ozone, et cetera, et cetera. And so I decided the problem has become twice as important. So when are we going to see this? When are we going to see this greenhouse effect? So teamed up with a famous meteorologist, Roland Madden, and we did what is called signal detection, statistical dynamical analysis, and we concluded the warming would be detected by 2000. See, until then for me, this was just a theory. And sadly, in 2000, the IPCC report acknowledged that we are seeing the warming already. That we said 2000, and you can see that's when, this is the global average temperature records. Of course, it goes up and down because the system is highly nonlinear, chaotic, dynamic. And I'm just showing this, just an example. Somehow, our community has not used the fact many predictions were made, they all came true. A famous Russian meteorologist showed the Arctic would warm much more. That was predicted, it's happening. And the Swedish Svante Arrhenius, father of physical chemistry, predicted when you warm the climate, the water vapor will go up. I'll talk to you, and that was confirmed, I'll show you that. So the thing why scientists like us are reasonably certain this warming is because of human activity, and it's going to get worse, is because the predictions theoretically made, and by climate models, there are hundreds of fantastic groups. All of them are coming true. That's what scares us. We thought nature is more complex, we have missed something. We don't seem to have missed anything so far. So my own work, like I said, I'm going to show you some satellite data. Now I'm going to walk you through what persuaded me we are looking at an existential threat problem, okay? So the satellite I helped launch with NASA's help is looking at the greenhouse effect of the heat flow in and out. Then we did field experiments. Last 10 years, in my group, we developed unmanned aircraft. These are small, 2 meters wingtip to wingtip. We miniaturize instruments and we package them. These aircraft were sent to Iraq. I found that company, and what we turned a sword into a plow for good use. So I'm going to summarize what we found from all that. Let's talk about this satellite radiation measurement. What I'm showing you is sea surface temperature, okay? There is some bizarre phenomenon. The ocean, temperature increases. If you look at east of Indonesian archipelago, the dark red, that's about the maximum temperature the ocean gets, 30 degrees. So I thought, if warmer air holds more moisture, if I look at the greenhouse effect from cold ocean to warm, the greenhouse effect should increase. So how did we pull that? Remember, I said the greenhouse effect is a blanket. So I need to estimate how much heat did the blanket trap. So we estimated the emission coming from the ocean. That's a simple Planck's law. And my telescope was measuring the energy coming out. So we subtracted the thickness of the blanket. So on the top, I'm showing sea surface. This work, by the way, was done by an undergraduate student at the University of Chicago. This was the thickness of the blanket we pulled up from satellite measurements. There was a phenomenal one-to-one correlation. We then looked at it seasonal, interannual. When the atmospheric temperature increases, water vapor goes up, okay? Going back to the bedroom analogy, so you have a blanket, keeps you warm. Then you say, add one more, add to the thickness of the blanket, your body warms more. How do you cool yourself? You evaporate moisture, right? When you sweat, that's what happens. The water carries the heat. Ocean does the same thing. The problem with that is your body, in this case, ocean surface, evaporates to get rid of the heat. But that water vapor evaporates, it's a powerful so you're adding to the thickness of the blanket. Okay? And there's numerous data on this, but so that water vapor feedback is the biggest gorilla on the table. Okay? Otherwise, the warming would be at least a factor of 2 lower. And the unfortunate thing here is that water vapor feedback doesn't involve any complicated phenomenon. The thermodynamics demands when you increase ocean temperature by 1 degree, the ocean will evaporate somewhere between 6 to 15% more moisture. The other thing is the capacity of air to hold moisture expands as you increase the temperature. That's why summer is warm and humid, winter is cold and dry, the moisture is wrung out. We did find something very peculiar. There was another professor from Oxford who worked on this too, Ray Pierhammer. When we went to that warm pool, remember the dark red, the blanket was getting much thicker, it was not able to radiate its heat away. It's what you call the runaway greenhouse effect. But it's not hurting the planet because it's in a small area. The dynamics is able to pump that moisture out. But when you increase the ocean temperature by 6 degrees, that red isotherm area is going to come to southern tip of England. You are just increasing the whole red area. Then it's not clear to me whether this so-called super greenhouse effect is going to be taken care of by the dynamics, okay? There was one anomaly we found. We were using a ship to measure sunlight reaching the Pacific Ocean. It was about 10 to 15% less than what the model said. And the only way to explain it was there was some dark substance in the air. So Paul Crutzen, who was head of Max Planck and got a Nobel Prize for his work on Antarctic ozone, and I planned this experiment to see what that dark substance was. And we had 6 aircraft, 2 ships, and the Europeans generously moved the meteosat over the Indian Ocean for the first time. The meteosat is over the Atlantic looking at from Africa. And we found what the dark substance was. It's called soot, or black carbon. It was being shipped, you can see on the other map, during that season, the air is northeasterly, takes the entire pollution from India, Pakistan, and Bangladesh, and dumps it on the Indian Ocean. And by making chemical measurements, physical measurements, we found the black carbon was cutting sunlight going into the ocean by 10%. That's not where the story ends, unfortunately. We did the UAV experiment. Here, I'm in an aircraft. I'm 25 kilometers away from Mount Everest. And I'm looking south towards Nepal and India. You see the brown cloud. And then the Italians set up a site that by this time, UNEP started supporting this Greater Atmospheric Brown Cloud project. And Achim supported even more, and it became a policy. We found that black carbon was settling on the glaciers and melting the glaciers. Why? Because black carbon is the most efficient absorber of sunlight. Okay? So some of the melting we did use was coming from this black carbon. The point I want to drive home, there are 2 problems going on at the same time. The global problem of CO2, and every region. I can spend hours talking about how we are hurting the planet, every location, okay? So I want to go to the, let me give you advance notice. The depressing part of the talk will finish after 5 slides, and I will go to the good news. The good news is there is still time to solve this problem, so don't forget that, okay? So sea ice, remember I said the Russian climatologist Budiko predicted in 1955 that the sea ice will retreat. And when you retreat the sea ice, he said more sunlight will will be absorbed by the ocean that will amplify the warming. So I had my student, Christina Pistone, and Ian Eisenman is a faculty at Scripps. So we went back to that satellite experiment which I launched in 1975, looked at the data, and to our shock, we found, comparing from 1979 to 2012, the dark areas, how the sea ice has expanded, but that's not a surprise. Other people have shown that. But what we found out was that the sunlight absorbed by the Arctic had gone up significantly. And it is equivalent to emitting another 250 billion tons of CO2. That is the force multiplier amplification. It was even larger than what Boudica had predicted. And very few models, all models show this, but the amplification they get is smaller, okay? Sorry? Oh, during this period, 79 to 2012. Good question, thank you. So we're not seeing anything positive of this resiliency of Mother Nature. Remember, same thing happened in Antarctic ozone. That work was challenged, trivialized, and the British discovered the Antarctic ozone hole, then everybody changed. But we waited for a disaster to react. The last thing I want to mention, I know every time I talk to my British colleagues and friends, they complain about the weather. I want to give you good news. The clouds you're experiencing is helping the planet cool itself. The so-called extratropical storm track clouds, they are white. Anything which is white reflects sunlight. So we had shown using the satellite data, without the extratropical storm track cloud, that alone, let's say if it disappears, thought experiment, the planet would heat up by 15 degrees. It's coming from the satellite data. And we found it had retreated by about 200 kilometers. We didn't publicize it. There was some problem with the satellite data. Then in last year, 6 groups promoted by a finding went back, cleaned up all the data, and they reproduced this retreat. This is not even community, even the climate science community is not really sensitized about this. This is one of the most sensitive things. If these clouds keep retreating further and further, you're going to lose the Atlantic is going to get enormous more sunlight, okay? So that's, there are 2 more, I'm not going to go into that. That's what is persuading me. What I thought was improbable is not so improbable after all. I'm not going to touch on the rainfall part. If you see this, last 50 years, the sub-Saharan Africa experienced major drought, and Professor Tim Palmer showed it was because the temperature gradient of the Atlantic has changed. And then another scientist from Australia showed it has changed because of polluting aerosols. Aerosols cut the sunlight going to the ocean. That's what I meant. There's a global problem. There's a lot of regional issues going on. So now let's, so far talk about the physics, chemistry of it. Let me now talk about what else is happening. This study was published 2 weeks ago. Scripps is working on this. The oxygen level content of the ocean.
Microphones comes out.
Oh, sorry. You can't hear me? Can you hear me now? No, it's not working. Is it? I was counting on this. Maybe I'll hold on to. Can you hear me now?
Yes.
Very good. Not to worry, I didn't say anything important so far.
The lapel's not on the lectern.
I'll
It's not on, it's the lectern.
This one?
Yes.
Okay. Yeah. If you didn't hear me so far, you missed the worst part of my talk. There's nothing but depressing stories. Now we're coming to the cheerful part, okay? Not yet, one more. So the oxygen level is going down in the ocean. And these scientists deduce, why is it going down? And look at this bottom one, most of the decrease in the Arctic Ocean, because the sea ice is gone, you have intense sunlight coming in, the ocean is getting stabilized. The ocean gets the oxygen from the atmosphere, but that's not going down. The Arctic apparently is becoming a little bit more stable. And then other thing is, the warmer the ocean is, it spits out more oxygen. And then we know the acidic ocean is getting more acidic. And the other part I want to touch on is extreme weather. Just look at the statistics compiled by WMO last 4 years. Horn of Africa, due to a drought-driven famine, lost 250,000. Okay? US, the Sandy storm, cost us 57 billion. India lost 4,000 lives from the heat waves. And the other studies, what we think 3 sigma events, extreme events, have increased by a factor of 10. Okay, they're not 3 sigma, they're getting into 2 sigma. And you know the European heat wave 2003, 70,000. This is just, we can't yet claim this is all called coming from global warming. We know the extremes are not becoming so extreme. It's getting more frequent, okay? But this is what you would expect from climate change. And the last one, I'm so sorry, I have more depressing news to say. This was done by my student, he's in Australia. And what he did was looked into heat stress. And to understand it, you have to go to something like wet bulb temperature, but I'm not going to bore you with that. Basically, our inside body temperature is 37 degrees Celsius, and the skin temperature is 35. You need that 2-degree temperature difference to ventilate the heat. You know, when you're resting, your body generates 100 watts. Equally, you're having a 100-watt light bulb. I'm generating 200 watts. I'm too stressed about this talk. But what happens? Air temperature becomes 35. You've lost the temperature gradient. So right now, apparently it doesn't happen anywhere. The maximum is 31. You increase the temperature by 7 degrees. They say a third of the planet could become not habitable. Okay? So the health effects alone would justify, forget about climate change. I don't know how many of you know, fossil fuels kills 3.5 million every year. And then the productive work hours lost is in millions of hours. The sad thing is, I know I'm going to get a pushback from economists, but I have to say this. Economists call this externalities. To me, killing is the most internal thing that can happen to us. We have to factor in the cost of fossil fuels. We are not, because it is being called externalities. So what persuaded me to call this catastrophic and unknown is the burning embers diagram, which IPCC came up with. They took 5 categories. The left extreme is biodiversity and extinction. 10 days ago, top ecologists got together at the Vatican, and they released a statement. They're saying 50% of the species known to us would be extinct due to habitat destruction and climate change. So everything is connected. The other 4 categories, what they call high risk, kicks in all categories by the time you are 3 degrees, and they didn't even go beyond 5. By the time you go to 5, all 5 categories become very high risk. Okay? So now I want to address who is responsible. Okay? And who is going to experience this existential risk? 50% of the climate pollution is caused by the wealthiest 1 billion. I call this top 1 billion. I'm within the 1% of this top 1 billion, just by my travels and others. So I'm not pointing fingers. This is something we all have to recognize. Contrast that with the bottom 3 billion. This woman, I stayed in her guest house next to her hut. She's cooking my breakfast. And her husband was my taxi driver.
from Delhi. That's because there was a drought, wiped out their livelihood, so the husband lives in Delhi as a taxi driver. They are subsistence farmers. That year, they're depending on that year's rain. Imagine 3-degree world, 2-degree world, major drought. Where are 3 billion going to go, right? So their contribution to the emission is only 5%. So I'm setting the stage now to take you into why I went to the church, Vatican, to look into this problem, that this has become a huge ethical issue, okay? So I finished talking about the BAU, and I said there is time, and now I'm going to how to go from the red curve to the green curve, okay? So to do this, I teamed up with 50 academics from University. You know, we have 10 campuses, Berkeley, Los Angeles, Santa Barbara. Well, there were only 3 climate scientists. The rest of them are political scientists, humanities, social scientists, anthropologists. I was curious, what IPCC has this definition for solution. What would this group say? How to solve the problem? Okay? And recognize there are 2 time scales. By 2030, we would have put the 3rd trillion. Miles Allen did a famous study in which he says all we can emit is 1 trillion tons. Mine is carbon dioxide, Miles is carbon. He uses carbon. I use the weight of the CO2 because that's what causes greenhouse, so we are consistent. So by the time you emit the 3 trillion tons, you have committed the planet to 2-degree warming. It's not going to show up immediately, so the public is going to think, oh, it's okay, it's only 1 degree, 1.5 degree warming. By the time you go to 2050, you would have committed to 3 degrees. So that's the urgency. That curve has to be bent at least by 2030, the emission curve. So this is what this group came up with. That we put the 10 solutions under 6 clusters. The left one is, of course, science solutions. This is what numerous groups have worked, including the Oxford group. But what rose to the top was not technology, was not market regulation. We had the top economists from Berkeley working with us. And it took a lot of fist fighting to decide the priority, but finally societal transformation came to the top. After this, and I've worked with a lot of economists and others, and I'm firmly now convinced, without societal transformation, we're not going to solve this problem. Why am I saying that? For example, in San Diego, I have solar in my house. After 5 years, I'm making a lot of money. Solar is already cheap, but nobody has changed to solar. It's not that they are, obstinate. Everyone has so many expenses. We have to prioritize it, okay? So let me just quickly run you through the science solution, then I'll come to the societal transformation. To get this near-term problem of the warming exceeding 2 degrees by 2050, and then long-term problem of huge 5-degree warming, we have to pull 2 levers. First is carbon dioxide, okay? It has a huge inertia, so whatever we do, we have to make sure that curve starts bending. Remember, the Paris doesn't bend the curve. The initial commitment is, instead of the emissions going up like this, you bring it to like this. What we are talking about is to bend it, okay? So if you start bending by 2030 and go to carbon neutrality, but to get the near-term change, you can bend the curve for short-term pollutants. I talked to you about HFCs, there's methane, and black carbon lifetime is a week. That alone kills 3.5 million people in the bottom 3 billion. And you ask, what's going to happen? How much sacrifice? If you bend these 2 curves, air pollution is gone, climate pollution is gone, and what you're left with is a phenomenal, beautiful planet where you're using electricity, solar, wind, and renewable sources. We are not asking people to go back to the Stone Age. We are asking people to go to the 21st century, where we can live in the future. And Akim has pushed this point. Green economy, everybody benefits, and we avoid 7 million deaths. Air pollution alone, starting from 2000 to 2016, has killed 52 million people, including many in Britain. It's everywhere. That air pollution doesn't target only the poor. We all breathe the same air, okay? And the thing is, the technology is for short-lived, but it's already there. CO2 technology is almost there. There's some innovations needed. That's what this group can be. I'm going to skip this. Let me get on to the topic, main topic. So, yeah, until about 3 years ago, I said all we need to do is this cut CO2 and SLCPs. That just takes the middle, that 4 degrees. It doesn't address the 6-degree problem. So take that probability all the way to the left of that dangerous curve. We found we had to pull a third lever. That third lever is just sucking the CO2 out of the air. It's called various names, CCS, carbon extraction. And we found, unfortunately, you have to take 1 trillion tons of CO2. I think Miles has come to the similar conclusion. What that means is starting from 2030, we have the technology to draw down 16 billion tons of a year, and you have to do it for the next 60 years. And to give you an idea what 16 billion, our current emission is 32 billion. So I don't want to trivialize the task. It's a huge amount, but we have to do it. I think the only way we're going to do it is think about that 1 into 20 odds of the plane coming down. We are sending our children on that plane. So once I realized ethical issue, this is 2004, by then it was clear to me we're not going to do anything about climate change. The discussions did not even recognize the urgency of the issue. So I was nearly depressed. I was 60 years old. I saw my whole life as a colossal waste. I wished I should have stuck with my Impala. I never got into this field. And then I got an invitation. I'm sitting in the middle of the Maldives in one of the chief's guest houses. And I opened my email after hard day work with the aircraft. And the first letter starts with Pope John Paul II. What would you do if you're sitting in an island and the email says Pope John Paul? You're going to think it's a spam email. I was going to delete it. Somewhere next morning I got up, and it was a genuine letter asking me to join the academy. The Holy Father personally admits you. What I found from this academy is only 80 members, about 35 are Nobel laureates. It's truly international in scope, multiracial in composition, and non-sectarian. I didn't know this. So I joined the academy. At this time, Pope John Paul II was asking me, are you an Indian? I said, I was an Indian. Now, unfortunately, I've changed my nationality. Because they wanted Indian scientists too. Anyway, I was thinking, once they discover I'm a Hindu, they're going to throw me out. For 5 years, I was going to academy. This is the time they're going to find out I'm not a Catholic. And then Pope Benedict appointed me to the council. The council runs the whole academy. And that's when I discovered. And I have, without any aspersion to any other religion, the Catholic religion is so accepting of the science. In a famous meeting we had 2 years ago, a Nobel laureate in biology told the Pope, Pope Francis, that biology can explain everything, right? And the Pope Francis said, I don't have any problem with it. We never claimed God is a magician. So God also, anyway, so we organized a meeting 2 years ago, and that was a meeting, Akim also came. We teamed up with the economist, Das Gupta, from this other college, southwest of you. We proposed to the church, sustainable humanity, sustainable nature. And Pope Benedict loved it. He appointed a cardinal to be a co-organizer. And the church added one more phrase, our responsibility. Until then, I had never thought of our responsibility issue. That's what made me work to find out who is polluting and who is receiving the bad side of the issue. So after the meeting, I briefed to Pope Francis. All I had was 2 minutes. There's many things wrong with this photograph. First, 2 Hindus advising the head of the Catholic Church about climate change. And the second thing is, normally when the Pope receives you, it's in the most spectacular room you can think of. Amazing frescoes, paintings nobody has ever seen. And this Pope, I'm waiting there, picturing this audience, and there was a small car, I think it was a Fiat or Ford Pinto, and somebody got out. You remember that, Hakim? Pope Francis just shows up in front of us. So I had to give a parking lot pitch to the Pope. So I said 2 things to him, that climate change problem has become a serious problem. And the second thing I told him was, most of the pollution comes from the top 1 billion, wealthy 1 billion, and the poorest 3 billion are going to suffer the consequences. So at the time he's smiling, he asked me in Spanish, what can you do about it? So I told the Pope, one of my saddest things is I don't know Spanish, because I live in a city, San Diego, half is Spanish. So they translated to me, so the Pope asked me, what can you do about it? So I told him basically, look, you're become a global figure, you become a moral, ethical figure, this is an ethical issue. If you can just include in your speech, ask people to be good stewards of the planet. And after that, he was anyway coming to the climate change problem. So where am I taking this? If you ask the question, why are we not taking action on climate change? Paris shows there is agreement from the top, but there's no public support for taking drastic actions, right? Politicians respond to the public. So I'm starting on this, that we start an alliance between religion, science, and policy. I'm not claiming it's going to work in the UK. I hear that most of you don't go to church, but in the US, the 40% of the population who does not like climate change, or they do not trust it, they're all religious. So I thought scientists need a forum to talk to them about this problem. In the US, it has become so political. It's not a political problem. It's a human problem. It's a science problem. So I've done this about 15 churches. My big breakthrough came 10 days ago. The American evangelicals asked me to address them, 150 of them. And they put in the invitation to the evangelicals, only respectful questions would be admitted. So next Friday, around the same time, this is happening. And if I don't survive it, I know you will hear about it in the press. So I'm telling you this simply, the biggest service we can do to push this problem before it goes disastrous, we talk to our neighbors, our citizens. We don't have public support. We can pretend we have, we don't. The sort of drastic, to pull 1 trillion tons of CO2, that's going to require massive public outcry. That's how California stopped its pollution, came from the public. And then the top responded. The other thing we are doing in this is that that's UC50, it's our vision that the only way we're going to solve this problem is to create new people getting into the field. So we are launching an undergraduate course. And the hand is symbolic, and I have a remarkable student who's working with me. I told her name is Astrid. Astrid, get me an image where we can tell our next generation, we created this problem. We are not going to solve this, but at least we want to give you the tools and we'll give you a damaged planet, but we'll give you the tools how to solve it, okay? So our vision now, we received a huge education grant. We're going to float this course in California, all the 10 campuses this fall, and then we'll port it to all the state colleges in California, and then redesign the course a little bit, and then take it to the interior America. I'm already talking to people in Kansas, Indiana, and Texas to create what I think 1 million climate warriors. This problem is ultimately going to be solved by those who are in the mid-20s to 40s. But we need to give them the tools. I'm not asking about young people going protesting this. Give them a critical eye and a hopeful heart. That's it. The slogan is from a Harvard psychologist. I want to conclude last with this project, but I want to find out how much time I have. Have I shot past the time?
Yeah,
Close to. I mean, about 3 minutes, I'll wrap it up. The other is, I firmly believe we have to figure out giving clean energy to the poorest 3 billion. Not necessarily for altruistic reasons, for selfish reasons. What's the use if 4 billion convert to clean energy? They're going to jump into the cheapest energy. So if they 3 billion start using coal and gas, we are all in the same water that you are seeing at 6 degrees. So we have to solve both problems, okay? And so we addressed the cook stove. We started a project called Surya. And this cook stove cuts down all the emissions, cuts down the CO2 emission by 50%, wood consumption, and cuts down all the super pollutants by 90%. But the problem was too expensive, it was $70. So my 2 daughters are the lead artists. Nitya, my eldest daughter, she was the high-powered wireless technologist. She used to come and boast to me how she was an Intel making 6-figure salaries. I'll always tell her, why don't you do something useful? After 3 years, she got tired of this, quit her job, and started an NGO and working on this. So what she designed is a simple sensor, which is attached to the stove, so that as soon as this woman uses the stove, the sensor keeps track of how long she has used it. Then I give Nitya an equation to convert that to carbon credits. And so the woman gets the stove from the bank, and Nitya converts into a smart stove. And then we created a climate fund. I got a donor. And so he put the money for the carbon credit. And then we Vodafone worked with us. We send the money to the woman. So this problem, which has not been solved for centuries, suddenly it looks like it can be tracked. The women are now using the stoves for many reasons. They know about the health issue. They know that we tell them not about their health, nobody cares. When you see your children, because she's holding the child, and the smoke is. And the other reason is they all feel they are joining the modern economy. The women get the money. We make sure it doesn't go to the men. Many of them drink with us. And the women have become entrepreneurs. And I want to say the other daughter, Tara, who's the one leading this, she is having discussion with the Oxford Business School. We have the thing worked out. It has to be scaled up. We need business folks to do that. I think I am done with this. So let's skip all this. I'll skip that too. The thing I want to leave with you on the science side, I can just say it from my personal thing. It is a real possibility if we ignore this. Just for the next 30, 40 years, this could slip into an existential threat for the 3 billion, definitely. But how can it not be an existential threat for us if 40% of the population are going to be wiped out? The second message I want to leave is that it is still a solvable problem. Thank God we have another 15, 20 years to solve it. But given all the current political confusion, each one of us need to work on it to communicate it to our neighbors, our relatives, and that bottom-up support has to happen. I took religion to go that path. You have your own path to do this. Thank you.
Thank you very much for the really inspiring speech. And might like a microphone, or we just share a microphone.
Yeah,
Questions? We have time for questions. Oh, I should warn you all that this is being live streamed and potentially recorded. So if you're worried about that, run away or don't speak out. Any questions? Yes, please.
What do you think of the divestment movement? And do you have, I belong to fossil-free Oxfordshire, and we just convinced the conservative Oxfordshire County Council to add climate change to their risk assessment. This was a victory this morning. But is there anything you could advise people on in terms of the divestment movement?
Like I said, we don't have much time. We cannot have a single moonshot. We need to try everything. All of them is going to help. But the key thing is, without public support for drastic actions, we lose the time. So if someone has, let's say, only a few hours a week to spend on this problem, we would have a much more impact by bringing others into the fold. We know what happened if you leave vast, in America we learned, we left behind 40% of the population. We have to bring everyone on board. And I know I'm asked this question many times, should I reduce my carbon footprint? I said, yes, but if you can only do one thing, please do this. Talk about the science that's based on data. It's not junk science, and there's not much time. You are sacrificing your children and grandchildren's future, not yours. So those three have to somehow, but there are others. Please don't think I know the answers to all of this. So that's why, but if the divestment definitely is going to help.
Thank you. Just to follow up on that, great talk. What does that conversation look like, particularly in the US? Because obviously, if it was just the science and convincing people that this is real, this is reproducible, people have done this, you should pay attention to that, I think that would be an easier conversation. But we're having this like post-factual weird period right now. But we're also having a hard time convincing people in the US that we should help this bottom 3 billion and sacrifice some of our own, day-to-day benefits. So if I'm having a conversation with a friend tomorrow, what does that conversation look like actually?
Yes, it's very series of complex questions, but excellent questions, very insightful. I'll just tell you based on, first of all, you have to know, I think particularly for the young people and students, I'm an atmospheric physics guy. I have no business talking about these issues. This problem has gone beyond climate science. It went beyond climate science a decade ago, but now we recognize this problem can only be solved by social scientists and humanities, lawyers, anthropologists, economists, etc. So the reason I'm saying that is, if this problem is not solved by 2050, I'm going to blame the social scientists and humanities. It's your problem to solve. my experience, talking just with the church folks, they were so insightful questions. And then, when you look at it, I'm telling people this colorless gas which comes out of your car is melting glaciers, swelling up the entire ocean. It's a hard thing to get your hand around, so we have to be patient about that. We cannot expect people to say, yeah, I trust what you say. So I'm very encouraged reaching out to the people. I tried it for 2 years, otherwise I wouldn't have proposed this here. But you have to understand, before one of you start going into the church, my entry point is I show them, I have another photograph, the Pope hugging me. Once I show the photograph, it sort of takes care of many of the questions. So be careful about trying this. But the conversation in the US, on the positive side, I'll tell you where I'm saying we need public support. 60% of Americans say, climate change is caused by human activities. Where it falls off the table is, some of the skeptical economists cleverly put 8 priorities. Climate change is 8th, or whatever, give 15 priorities, climate change is 15. And then, we can say, oh, these are deniers, but these people are struggling for jobs, right? So many are struggling. Particularly, when I visit in Kansas, Indiana, it's really sad. So poverty is just not in India or Pakistan. It's in the US, 1/3 of the children in San Diego go hungry every day. So this one I'm going to blame on the economists. The economy has left half the population behind. So then we are landing on one more problem. If you're struggling for your tomorrow's food, are you going to say that's... So we have to have an understanding of that issue. That is where I think we need the social scientists. They know what makes people change behavior. The anthropologists I learned yesterday, they cut across anthropologists on the one hand or natural scientists, they look at empirical data, but they look at people's culture, humanities, and then they look at behavior, social science. So I'm thinking anthropologists could help us bridge that gap.
Yes, please.
Hi, thank you so much, Ram, for your talk and for updating us on the very latest science. And thank you also for your decades of work on this. You've been trying to get the message across for so long. I have to say, I do sit here, I've worked in climate change, carbon markets. I've worked for a company promoting efficient stoves in India and Africa. I visited villages in India. And this is 15 years we've had talks very, very similar to this. I mean, I remember one right when I first heard about the possibility of runaway climate change. Mayor Hillman, who was publishing a book, saying the same thing, and if we don't act urgently, we're buggered, basically. And I was at Paris last year for the demonstrations, and the treaty was signed, which was such a relief. But we're going the opposite way now in so many ways politically. And yeah, I think your wake-up call is important, but it is very hard for someone like me who's worked for 10 years to hold on to that sense of hope that we can turn things around, especially when you're talking about such and such by 2020 and such else by 2030. And I'd like to just flag up to everyone in this room that there are people, and I'm involved in slight ways myself, but very brave people who actually get out there and stop stuff from happening. And make, direct action. Last year I was part of a group of over 100 people who went down to an open cast coal mine and shut it down for a day. And it was all ages, all backgrounds. And so people are actually saying enough is enough. We don't need to debate, we don't need to listen to the BBC putting pro and con, let's just stop this, let's put our bodies in the way. And that is one response that people are having, and I think that's a very important one. And I guess I would just say, sorry, I've said it quite a lot, but for those in the room, that is an option of response, as well as your efforts to engage with the religious community, to get involved in those groups. I don't know if you have any views about maybe how that ties in with your work to educate, and what the role of a more civil disobedience, basically.
Right. Now I've gone way beyond my expertise. What I think is that, there are certain actions which makes us feel good, right? But we don't have time for those kind of things to work its way up. We could stop one coal mine from doing. So, again, you should say what I say in this with a great bottle of salt, it's not a pinch of salt, is that we have to figure out how to get the public on our side. See, it needs public support, then it needs the politicians to do this. Individual actions, I hate to say this because there are a lot of young people there thinking, oh, I cannot do it. Individual actions help to keep you not getting too depressed about it, that I'm doing something about it, right? But I personally think it's getting the public support, and I learned something remarkable from Akim talking to him. After all, we are not asking people to go back to the horse buggy days, right? There is a bright future here. Just imagine, whole of London is on renewables, or Paris has the worst air pollution problem, no smoke. And I didn't even mention to you, last month, 10 powerful groups have come to the view the black carbon or air pollution is causing dementia. And there's a huge thing, but is that partly responsible for Alzheimer's? So we need to bring the health effects. We have tried talking to them about glaciers melting, polar bear disappearing. It's not worked. And I a little bit would like my climate scientists to support me. They still talk about 2100, 2200. How can people get their head around 2100? Or even our presidents are not able to do it beyond 4 years. So we have to follow what Einstein said. He said, craziness is doing the same thing over and over again and expecting a different result every time. We have to change our tactic. We have to talk about the health effects. You're killing yourself and your children. And we have to talk about, give them an impression of the beauty of the planet with the renewable technology. No coal mines, no lung disease. So we need to change our tactic, and that is where I'm hoping, particularly with the political chaos going on, I feel institutions like Oxford and other top institutions, which hold this respect, have to keep the ball going till the political situation straightens it out. But again, the social scientists and humanities, they have to get in. It's not, they can't say it's a problem of technology, it's our problem.
Okay, there's time for one last burning question in the very end. Please, a short question.
You mentioned the destabilizing feedback loops, and you argue that the water vapor feedback loop is the most serious. Are you confident that the release of carbon through permafrost melting isn't more serious?
Perfect question. But how many depressing slides you want me to show? I am given 45 minutes. I have to persuade people the planet is coming to end in the first 20 minutes and then talk about solutions. Absolutely. The permafrost could be the biggest surprise of all. At least water vapor feedback we understand, we can measure it, and at least alert people it's going unstable. It's not unstable now, don't get me wrong. Permafrost, methane escaping, and even CO2, huge issues.
Okay, thank you very much. I think it's time to draw this to a conclusion. Let's thank Ram again for a really inspiring talk.